All right. Hi, everyone. My name is Taylor Palmer. That's a picture of me. Hey, someone I know. I'm a UX designer at Lucid Software, and the title of my talk today is Prototyping and the Realism Threshold. So I'm glad that Teresa was able to prime you and get you excited about prototyping. Now I'm going to come in. We actually planned this to tag team it. That is not true. But I'm going to talk to you now about how to take your prototypes to the next level, and also introduce this idea of the realism threshold. So I've been an active participant in the Product Hive community for the past couple years. Anybody here that's heard of Product Hive? Yeah, all right. Got a few of us. If not, you should check it out, producthive.org. But after I've been a participant there, I'm really excited to now be participating in front. So my talk, Prototyping and the Realism Threshold, is about when product managers and UX designers should use prototyping as a learning tool, and about some ways that Lucid has been able to do that in the past. So to begin, let's take a look at the state of prototyping as it exists now. In 2017, UX is still kind of a buzzword. Everybody's trying to jump on the UX and design bandwagon and jump on the Silicon Valley tech startup model. And so as a result, there's a lot of excitement and innovation around design and around tools. And what happens is you get a lot of tools. You get some 63 or some odd different available prototyping tools that we have to choose from, which is kind of a blessing in disguise. It's cool because we have a lot of options, and we can take it in a lot of different directions, but it's also kind of this paradox of choice, right? Which of these is easiest to learn? Which one's the most popular? Which one is the best? I'm not going to attempt to answer that question. I'm sorry. If you would like to argue about design tools, I'd be happy to do that in Slack after the talk, so feel free. But as I was writing a blog post about how to choose better design tools last year, I made a simple site. It's called uxtools.co. It compares a lot of these tools. These are some prototyping tools that are compared, their prices, the things they can import from, the different features that they have. And this got a little bit of buzz, and it's a side project of mine now that I maintain on nights and weekends. But I'm actually here to tell you that this is not enough for you to make a tooling decision. Just seeing some checkboxes and knowing the features that are available to you is not enough for you to decide the tool that's going to make the most impact on the project that you're on. So today, I want to introduce a system that will help you make those choices, that will improve your understanding of prototyping and the tools associated with them. So to do that, I want to describe three different types of prototypes. I think the word prototype has become a little bit overloaded, and I think we use this word a lot to describe several actual different use cases. So let's improve our vocabulary. Let's talk a little bit more about three different types of prototypes. The first is proof of concept. This is a prototype in which you've probably been working with static designs and mock-ups within Sketch or your tool of choice, and now you want to introduce some motion and interaction into it because you need to kind of figure that design out for yourself, and to really make a decision, you need to feel it move and be able to click on it and interact with it. So you're probably making a proof of concept type prototype. The second type is stakeholder feedback. With this kind of prototype, you've made again, some sort of interactive prototype that you plan to present to clients or leadership or other stakeholders, product managers, engineers, and you're using it to try and generate some consensus. You're pitching an idea, you're trying to get buy-in on something. So that's stakeholder feedback. And the third one is user testing, the one that we're all probably most familiar with, which is creating a prototype to put in front of customers or participants or users to be able to learn from them and get their feedback about your design. These are three actually quite different things. They have different goals. They have different outcomes. The tools that you would use for them, I would argue, are quite different. So I don't think we can talk about them like they're the same thing. To just use the word prototype to describe these, I don't think does justice to the nuances and intricacies involved in these objectives. For example, the purpose of a proof of concept prototype is to convince yourself that something is right. You've prototyped something so that you can see it, you are learning, you've added some elements of motion and interaction to try and figure that out and to learn from that. Whereas stakeholder feedback is likely about convincing others, bringing them along on this journey, and doing that through elements of motion and interaction. While user testing, on the other hand, is about learning from others through the elements of motion and interaction, but also allowing for the elements of autonomy, personalization, engagement, allowing someone to test drive that prototype and kind of take control of it on their own instead of sort of you just showing them something in a presentation like you might do with the other types of prototypes. So for that reason, because of the unique nature of user testing prototypes, I'm going to focus on those today. And I'm going to try and dive deep and really talk about what makes a successful user testing prototype. But first, because I know you'll ask, I'll give you a peek into the tools that we use for these at Lucid. For a proof of concept prototype, we normally use Principle. It's really quick. It integrates with Sketch. We pull those sketch designs right in. You can add some motion really quickly, and it's what you'll find our designers using when they're vetting things out for themselves. For stakeholder feedback, it's likely Principle if it's a relatively simple kind of state-to-state design. If we need to take it a little bit further, then you'll probably find us using Framer. Framer expands those constraints a little bit and lets you kind of get your hands dirty with some of the light code that Framer allows you to use and gives you some extended capabilities that Principle might not. Principle, however, is not very good for sharing. And user testing hinges on the ability to share and get your prototype in the hands of other people. So instead, we've used Atomic before for user testing. Atomic is basically Principle in the browser, and it has great sharing capabilities. You can generate links, send them to people, open it up right in the browser. So does Framer. So when Atomic doesn't quite get us far enough, then you'll find us using Framer to make those things and send them out. But there are actually times when Framer's not quite enough. Because every tool that you use, you are constrained to the features that the developer of that tool has allowed you to use. So if you tie yourself to one of these tools, you're accepting the constraints that they've imposed on you. And sometimes when those constraints aren't enough for us, we will use code for prototyping. And in fact, that's what I want to talk a little bit more about today. But in order to frame this discussion about tools and prototyping, I need to tell you a little bit about our product. I work full-time on this product. It's called Lucid Chart. And this is what it looked like when I came onto the team. Some of you might have heard from it. I've actually talked to a few of you in the lunch line in different places about using Lucid Chart. It's for creating technical diagrams, flow charts, user flows, journey maps. You name it, if the word chart is in it, we can probably do it. And while it is a very successful tool for what it does, it's had some problems throughout the years. It's grown really quickly, and as a lot of features have been added onto it, they've been sort of haphazardly tacked on wherever the icon would fit, and just kind of thrust it in, and we try and get it out to users as quickly as possible with not as much thought as probably should have been given to the information architecture of it, and where those things actually should have gone. So it's also a single-page app, you'll notice. So it's an editor. You're pretty much always in this screen when you're building, which means there's not a lot of state-to-state transition. Instead, it's very loaded with micro-interactions. There's pop-ups and flyouts and drop-downs and modals, all of those things happening on this screen. So a lot of the tools of the day are centered around state-to-state, right? Navigating between one screen to the other. Those don't quite cut the mustard for us because we need to create all of those micro-interactions. I'll give you a little peek about to see what the tool looks like today. This is Lucid Chart today after the redesign. The bones and the structure of it are similar. You'll notice there's still shapes on the left, an editing toolbar on the top. There's still a dock on the right. The guts of it remain the same, but we've made a lot of improvements to those problems that I mentioned about information architecture and being able to discover features and finding them and meeting the user expectations that they have for our tool. Those changes didn't happen overnight, though. That change is the result of about 4 months of user testing, as well as several more months of alpha and beta testing as an actual product. So let me tell you about the tools we used for those few months of user testing. Good old HTML, CSS, and JavaScript. Just standard web code. This is what we needed to be able to take our prototypes to the level that we wanted them. And we actually took it a little bit further, because there's a designer on our team named Corey who's very talented and knew some Angular 1. And so he sprinkled some of that Angular 1 magic onto our prototypes. And essentially, without getting too deep into the details of it, what that allows you to do is where normal HTML is written like this, open paragraph, hello world, close paragraph. Well, there are these cool things called Angular directives. And what those allow you to do is essentially make your own tags. So instead of open paragraph, close paragraph, you could say open Lucid Color Picker, close Lucid Color Picker. What happens when you use those tags is it will create a fully working color picker right in between those tags in your code. Once this was created, any other designer could come and pick it up, drop it into their design, and they had a fully working color picker. Once this was democratized and all of us designers could jump into it, we were all able to make these components and share them and use them, and it made for a quick and rapid code prototyping process as we were able to use these interchangeably. We had several of these components. We made a library of them that we called Lucid Particle. You'll see the example there of the color picker that appears if you use those tags, as well as several other color pickers several other components that exist for form elements and different things like that. So using all of these tools, we were able to create our prototype that looks like this. This is the Lucid Particle coded version of the prototype. And this is something that existed several months before engineering actually ever broke ground on this design. And we were testing with this for several months before we needed to hand it off. So it was cool. We had this really awesome timeline. We were out ahead of engineering. We were running with this prototype, and we were learning really quickly and iterating it every week as we learned from our participants. And I was really close to this project, and I was embedded in it and working on it for several months. And I've tried to condense the things that I learned about user testing with a realistic prototype like this into an easy-to-consume, digestible framework. So I did that in 3 easy principles. So these are 3 principles of user testing that I think will be valuable no matter what kind of user test you're doing or what kind of prototyping you're doing. Following these principles will be valuable to that testing effort. And because I've been so close to this project and so steeped in our product, I actually want to turn to some other industries and see how they've solved some of the problems of prototyping and user testing, while also giving some of the examples that we found and learned at Lucid. So I'll do that for each of these. The first principle is called illusion. It's the idea of making something fake appear real. And to illustrate the principle of illusion, I want to turn to something that is very near and dear to me, very close to me. That is the movie Star Wars Rogue One, which is a phenomenal movie. It's the prequel we all wanted and deserved in the Star Wars universe. And if you saw it, you know that one of the main antagonists is Grand Moff Tarkin, one of the sinister first Grand Moffs of the Imperial, regional governor of the Outer Rim, who ruthlessly took control of the Death Star from Commander Krennic, as you know. Thank you. He's played by Peter Cushing. This is him in the 1977 release of A New Hope. Great character. And this movie came out last year. Rogue One did in 2016. Unfortunately, Peter Cushing died in 1994. So how could he have possibly been in the movie Rogue One? Well, Grand Moff Tarkin was actually played by Guy Henry, who wore this rig the entire time he was on the set, and he mimicked the mannerisms and characteristics and the voice of Peter Cushing. And then the CGI agency conglomerate from the Disney Star Wars now ownership of this franchise stumbled upon this plaster mask of Peter Cushing that was actually created for a movie that he did several years back. And they took this plaster mask and they did a scan of it and created this really high resolution texture map for his face. So the result is a highly realistic rendering of Peter Cushing that you saw in the movie Star Wars Rogue One last year. Now, if you didn't know any better, and if you didn't know any of the context that I just gave you, you might have just thought that this was the mean old dude from Star Wars Rogue One. And in fact, that's what several of my friends and coworkers thought after seeing this movie. They were surprised to find out that he was actually computer animated, which means Industrial Light and Magic did a good job. Because that's what illusion does. That's the power of illusion. Taking something fake, making it appear real, causing you to believe what you're seeing and accept that as the truth. So that's what happened with Star Wars Rogue One. And sorry to ruin that for you if you didn't know that he was CGI. But now you know, because it's actually pretty amazing. It's probably some of the best human rendering ever done. But can you think of any CGI characters that have ruined an experience for you? Can you think of anyone, any movie that was just maybe so bad that you could not possibly dismiss that character? You could not possibly look past the flaws in that character. That's a huge distraction, and it doesn't allow you to believe. The illusion is not successful. Let me tell you about some ways that we created illusion within our Lucid chart prototype. So this is what a user would see when they opened our prototype. You will notice that it opens in the browser, so they don't have to download any sort of special viewer app or install any software or create any sort of account. Rather, they open it right up, and it shows in their browser just like a real product does, just like they would expect. And because of that, it appeared to be a real working thing, a real working app. This interface is fairly complex. We did our best to be as comprehensive and as thorough as we could to create all of the little submenus that you'd possibly want to discover. But as I'll show you, even though we made those menus, most of them are actually images. You can see how the browser kind of ghosts as I drag along it. That's an image. Open that one. Also image. There's another one. Guess what? Image. You can come over here to the right side. There's a bunch of menus built out here. Also an image. Still images, right? So this appears to be a very robust and built-out interface. It's actually just a sketch mock that we sliced up and threw into a few of the working components that we had of moving menus and panels and things like that. But the illusion was successful. It appeared that all of the working pieces were there that needed to be, and it was accepted as this real, capable product. Also, you'll notice that we have some shapes there on the canvas, on that white paper. Those shapes are things that you could move around. You could change the color of those. And really, it's just some HTML divs where we're just swapping the background color, whereas our real product has really complicated algorithms about drawing special lines and rendering curves nicely and things like that. We just made some boxes that you could change the color of. But the idea was there. And it created the illusion that you could still create a diagram and you could still drag out boxes and do things with it. So this was a successful illusion for us. But looking real might not be enough. You can't just put something up that looks realistic and expect it to be successful. And so the second principle of user testing is simulation. It's about mimicking realistic circumstances, getting the conditions right under which someone might encounter your prototype or product. So let's keep rolling with the space theme. Let's continue and look at another industry, but we'll look at a galaxy that's not so far, far away, our own. And let's talk about the NASA Mars Rover. So I think the idea of the Mars Rover is really fascinating because it's a $2.5 billion investment where they had to send their product 140 million miles away on an interplanetary journey. And we complain that it's difficult to release every 2 weeks, right? But this is something where you get one shot. You got to thread this needle and send this thing across space and hope that it lands and that it does so successfully, or else you wasted everyone's time and money and everything goes wrong. But check out just how risky this is, right? In full low-definition 360p glory, thanks to Amazon Prime, I present to you the rover landing sequence. This is the rover entering the Martian atmosphere. And it comes screaming in at what I calculate to be something like a gazillion miles an hour. But don't worry, this small piece of fabric emerges that starts to slow it down. And it's catching air, and that wind resistance is stopping it from going so fast. But don't worry, that precious cargo, that payload, dangles by a thread as it extends farther and farther from the parachute, continuing its fiery descent towards the surface of the Martian planet. As it continues to get closer, obviously, it's just a big lump of metal. It can't land like that. So a protective cocoon of balloons emerges. As that begins to get closer and closer in its descent, we don't want to drop it that quickly, so we fire the jets, we drop it off, and it bounces. Wait for it. It's going to bounce again. There it goes. It's going to keep bouncing, and this thing bounces and bounces until it can dispel all of the momentum that it picked up traveling through space. How do you possibly plan for something like that? How could you possibly get that right? And we've done it, apparently, multiple times, but that is insanely difficult to do. So, well, I'll tell you how you plan for it. If you're worried about balloons, well, what could go wrong with those balloons? Well, that rover has to bounce and roll across the surface of Mars. Well, here's one thing that could go wrong. If those inflate and we drop them on a platform and you simulate sharp rocks, guess what? Spoiler alert, balloons can pop. It's a good thing they slowed it down so that we could see the giant hole that emerges as it hits the sharp rock. But essentially, they had no idea what sort of terrain they were going to encounter. Was it going to be a huge cliff drop-off? Was it going to be a sharp rock, fine sand? Who knows? But it had to be ready for anything. So you can't go to Mars. You bring Mars to you. You create that Martian terrain in a lab, and you roll those balloons over it as many times as you need to make sure they're not going to pop. What about something like a parachute, right? We've seen parachutes work before. Seems pretty straightforward. But it's actually this game of ratios where a parachute requires a certain amount of air to expand and begin creating that drag. If the ratio is not right between the fabric and the incoming air, it causes this kind of squid thing to happen where it doesn't create enough resistance and you're still cruising at how many miles an hour towards the surface of Mars. So if you try that in a lab, right, you fire it off, and you're still not getting what you want, well, then there's a few things you can do. If you are Adam Steltzner, aka the Fonz, and you want to fix your parachute, you'll notice him here in this next shot, there he is. Then what you do as the Fonz is you take a look at the parachute and you fold your arms and you say, doesn't look like this is gonna work. And so you have everybody get their arts and crafts supplies together and get their markers and draw some pictures or draw some circles. And you take those arts and crafts and you hand them over to Uncle Jim, who has his fanny pack and his sewing kit. And he starts fixing that bad boy up, making sure that parachute works the way it should, fixing that ratio. There he is showing his handiwork. And then you throw it back up, right? You blow those fans as hard as you possibly can to try and simulate what entry into the Martian atmosphere might be like. Tensions are high. Let's see if it works. Whew, tensions are so high. We'll find out. Oh, there it is. They did it. They were able to simulate that. Look, it's so smug. So smug. He knew it. He knew it was going to work. He didn't even need to test it. But essentially, if you are unable to go to Mars, you simulate Martian conditions. You use fans. You use fake rocks. You use whatever you need to try and get the elements of the Mars rover and its components to respond correctly. So let me tell you some interesting things we did with our Lucid Chart prototype to simulate. When you typed in the URL for our prototype into your browser, this is actually the first thing you would see. It is a loading screen. It's something that users were accustomed to seeing on our product because our product has to do some heavy lifting. It's a very robust web app. Our prototype, not very robust. However, we simulated this condition in which people were used to waiting for things to load up. So they were used to seeing this on our product. They weren't surprised to see it when we launched the prototype. So they would fire it off, and that loading bar would go. And then guess what? Onboarding modals, pow. We were testing some different techniques for onboarding where we were pointing them in different directions with these tips, trying to call out things we wanted them to use. If you're thinking about stealing that for your product, it was not successful, so don't take that one. However, when they encountered that loading screen, they could kind of feel the gears turning on this, right? Like, oh, this has to load. This is quite the prototype I'm using, right? This is quite the interface I'm going to get a preview of. And then they would see this onboarding, which we're all used to being spammed with pop-ups now. That's just kind of the way of the world. And so this was no surprise. It felt very realistic. It felt very normal. And I won't go into all of the different things that we simulated, but for example, that orange folder icon on the top left, you could click that and actually get to a fake list of documents. That was kind of this escape hatch. If they couldn't figure anything out, they'd kind of go back there. And we tried to catch all the loose ends and simulate all of those conditions that might exist within our product when you're trying to use it. How could you possibly, though, simulate those conditions, or excuse me, how could you possibly test for those circumstances when they don't exist in your product yet, right? We were prototyping something that did not exist yet. So while user testing might be valuable for those types of things, this is how you get out ahead. This is how you get those learnings before any of this exists. You create it, you simulate it. So if you can generate that behavior, you need to create an outlet for it. And that brings us to the third principle of user testing, which is expression. It's allowing for personal investment within the prototype. And to introduce this point, I want to tell you about an experience that I had at a local company called The Void. Has anybody heard of The Void? Yeah, all right, sweet. Well, The Void is a virtual reality experience. I was able to go through their demo, and it was fantastic. It was really well done. It was a lot of fun. If you get a chance to check it out, they're just located a few minutes south of here. You should go take a look. But essentially what The Void has done is solved the problem of movement within virtual reality. So if you have your Oculus Rift or HTC Vive or whatever flavor of virtual reality headset of the day exists, and you put that on in your living room, and you stand up and try and walk, you are going to trip over your coffee table and destroy all of your furniture. And they're not meant for movement, right? They're meant as just kind of guided experiences to watch virtual reality videos or maybe play a game or something like that. But The Void solved that problem. They actually skirted that problem by creating these kind of stages and arenas that the virtual reality experiences are mapped on top of. So you're going through this stage of, I don't know, probably plaster walls and just kind of basic props, but what you're seeing appears to be much more than that. And the result is this very dynamic, very immersive experience. It's really cool. You kind of have to do it to really understand it. But I want to tell you about an experience that I had where I went through this Aztec jungle kind of course. I guess Curse of the Serpent's Eye is what it's called, according to this image. But it was kind of this Aztec jungle exploration experience where I went through this Aztec jungle, and as I was walking through, I would see a fire, and if I walked over to the fire, I could put my hand out, and it was actually warm. At another point, I walked by a river, and as the water was rushing by, I could feel the mist on my face. Then I came up to a bridge that began to collapse, and I had to decide whether I was going to quickly try and run and jump over the bridge, or if I was too scared and I was going to back away and maybe try and tiptoe around it. But I was able to do whatever I felt most comfortable with, and I was able to make that experience my own. When you allow people to express themselves like this within experiences, their real emotions come out, and they kind of show their true face. And that's what happened here, right? Participants are able to do whatever feels best to them and map their emotions on top of this experience in whatever way they see fit. Let me tell you now about expression within our Lucid chart prototype. Here are a few of the features that we built in, right? I told you that you could actually change the color of these shapes on the canvas, so you can do that. Then you can take those and you can save them, and we'd encourage people to use this the way they would normally use our product to the best of their abilities. We built a fully working file menu that had all of the options there. Any menu or icon that you could click on, we tried to make sure there was something behind it that you could kind of poke and explore. Pretty much any corner of this prototype that you could go to, we wanted there to be something there to generate a discussion and to evoke a response. So here you can also play with the full screen mode that we are testing and trying out. This is really expression through exploration, right? Something interesting happens when you take a product that people use every single day and that they rely on at their job and that they rely on for their career success, and you change it up on them, right? So we were presenting like, hey, this could be the new design of Lucid Chart. Give us your feedback. And so what happens is there's a lot of anxiety around like, wait, but I use this feature every single day. You better not have moved it. Where is it? And we would be able to say like, well, you go find it. See if you can find it and use it, because you can do that within this prototype. And that's where that emotion came out, right? That passion that this is my job, this is what I do every single day, like you can't ruin this for me. And we wanted to capture that and harness it and use it within this prototype. And we could only do that if they were free to explore and to be able to look for those things and try them. So that was really awesome, allowing them to explore, and we learned a lot from doing that, allowing people to do things the way they're used to doing them. I'll give you a little insight here. This is the secret to allowing expression within user testing. It's input. Most design tools don't allow for this at this point. Most prototyping design tools, a few of them are starting to allow for little text boxes and things like that. But this goes beyond just our normal idea of input as being just text. This is input as in making it your own, customizing it the way you would use it, rearranging things the way you actually want to use them. The more input you allow in your prototype, the more expression and emotion will come through in those prototypes. To give you an example of how that worked, we had introduced the design for page management that was not successful. We made some assumptions where some users of our product will have anywhere from 1 to 5 pages, and some of them will have all the way up to 120 and above. And we had made some design decisions that were catering to those 120-page users, right? These super power users. And frankly, we got it wrong, and we didn't want to get it wrong again. So this version of the prototype allowed people to express themselves through these page tabs in the way they normally would. We wanted them to name things the way they normally would. Maybe that's with some sort of identifying number. Maybe there's a nickname for the project, or they use page names as some sort of version control, or they include the names of people that are on the project. Frankly, we don't know all of those things, but we wanted them to be able to show us that in the prototype without just having to imagine how they would do that. So we could observe them, we could watch them type those things in. Maybe the important information was at the beginning or the middle or the end of that page name, but we could only know by letting them try that. The same thing goes for rearranging those pages. If they were to have 5 pages or 120 pages, we wanted them to be able to simulate that and to express the way they would normally work within this interface. So if that was through this tiled set and list, or through those page tabs on the bottom, whichever way they are most comfortable, show us how you would do that. Show us what's most comfortable to you and what would be most successful. And then we can introduce an even better design as we learn. So something interesting happens when you successfully include illusion and simulation and expression within your prototypes, because what happens is that illusion creates belief, that simulation evokes behavior, and expression invites emotion. And once all 3 of those things are present within your prototype, you begin to cross this line that I call the realism threshold. Essentially, the realism threshold is the point at which a prototype experience becomes real enough to evoke a natural response. So no longer are participants viewing this as some sort of fake or contrived experience or example, but rather they're treating it as if it were the real thing, and they're interacting with it in that way. Let me return to the void for just a second to expand a little bit on the idea of the realism threshold. When I was going through this course, the Curse of the Serpent's Eye, before I actually went into an Aztec temple, I had just put my gear on, I had my headset, my visor on, and I was ready to go. And I was in this jungle, and then a voice crackled in my ear and said, "Hey, go take a seat on that bench for a second." And so I hesitantly went over to the bench, reached out, touched it. To my surprise, it was there. I sat down on it and just waited for like 10 seconds, and nothing happened. And then they had me get up, and they said, "All right, go ahead, let's go." And then I went through and had all of those other experiences. And afterwards, I talked to them a little bit about it, and they talked about the need that they had to just allow the participant to slow down and accept that what they were seeing was reality and really buy into the experience they were having. Otherwise, virtual reality, especially this kind of like hyper reality the Void has created, can be a little bit disorienting when you're not actually really sure what to accept or what's really there. It kind of feels like this trickery almost. And when that happens, you get people who are really terrified to go through, and they're just kind of up against the wall, and they can't really loosen up and have any fun because they need to have that time to invest and buy in and accept what they're actually seeing. That's the realism threshold, right? Like, they needed people to cross the realism threshold to be able to enjoy these experiences. Likewise, in your user testing prototypes, if you can help people cross the realism threshold, you will get that much better feedback. So let me tell you 3 ways to know you're crossing the realism threshold. These might be valuable to you as you're kind of analyzing your own process. The first is having open-ended prompts. Does this sound familiar? Can you find the print button? If your user testing prompts sound like a Dora the Explorer episode, then you know that you're not crossing the realism threshold. This idea of like scavenger hunts, right? You're kind of guiding and biasing the feedback. Rather, what we were able to do is have these open-ended prompts like, how would you get this on your boss's desk, right? This diagram that you've just created, how would you get it on his desk? This really opens the discussion because this might be a person that never prints. In fact, their boss might have a strict PDF in my email only, or maybe I only respond to Slack, or by snail mail, or I don't know. But we were able to have these discussions because we had all of the outlets there for them to do that, for them to show us. Say, oh, well, what I usually do, I'll show you. I go up here and I click the share button, and I generate a link, and I send it over to my boss. And we learned something about the different kinds of users that exist within our products, as well as what they were likely to do and their tendencies. So open-ended prompts. Second, show, don't tell. You might hear yourself saying this, tell us how you would do this thing. Well, we ask our users a lot of questions, and we've done a lot of surveys and research, and 9 times out of 10, when we ask users to describe themselves, it's completely wrong, right? How many documents do you think you have? 40? It's actually 20. How many hours a week do you think you use our product? 20? It's actually 30, right? Like, it's really hard to describe yourself and actually quantify those things that you don't spend a lot of time paying attention to. So to ask someone to tell you how they would do something, probably not going to be right. Instead, we could ask them, show us how you would do this. Like, it's right here. This is the interface. Go do that thing that we just talked about. And then we could watch them do it, and it was this very pure usability test that they could actually use. The third one, no purple squares. Let me tell you what this means. If we put this nice, shiny, Lucid chart redesigned interface in front of a user, and we ask them to interact with it, and they think, oh, wow, look at those great shapes on the canvas. I want to click one of them. And then this happens. Illusion broken, right? These are super distracting, and they guide people to click on one specific thing, and it's just like these blinking lights that are calling your attention to something, and they completely bias the way you might interact with something. Whenever I get sent a prototype like this, I usually just end up trying to click all the purple squares, like whack-a-mole style, until it's over, because I can't click on what I want to click on. And I'm not one for strong language, and I don't throw this phrase around lightly, but purple squares are the Jar Jar Binks of user testing. Huge distraction. Thank you. Again, so those are ways to know if you're crossing the realism threshold. You might have a few remaining questions. I'll try to answer those in the time remaining. But Taylor, why would I want participants to think this was the real product? That's a great question. To be honest, we did not want them to think it was the real product. Well, sure, we wanted them to, but we did not tell them it was the real product. We said, hey, this is a prototype. This is the new design we're testing. Will you walk through it with us? And what would happen is it would feel so real, and there would be so much functionality there that they would convince themselves that it was real. And they would start saying, wait, well, this isn't working, and you guys don't have this here like you usually do. And we'd actually have to slow them down a little bit and say, no, this isn't the real thing. Remember, this is a prototype. But they would convince themselves of that. So this wasn't a goal of ours to tell them that it was real, but it just naturally happened as they crossed the realism threshold. Another question, but Taylor, why not just code the actual app, right? Because whenever we talk about designers coding, there's a lot of anxiety and fear that arises whenever we talk about a designer having to code. The difference is that final Lucid Chart product that you saw took about a year to build using very complex technologies and about 40 very capable engineers who touched it at one time or another and built out this robust product. Ours was 3 designers, each making their own prototype for about 2 weeks, and then iterating over that week over week over week for multiple months. So to ask this question and to justify that if you're ever writing code, it has to be production code, I don't think is fair, because you can code quickly and you can create quick and rapid experiences with code if that's what you need to cross the realism threshold. Which brings us to our last question. But Taylor, do I need to cross the realism threshold? That is an excellent question. And to be honest, I don't know. I don't know what you're trying to learn. I don't know what your product is like. I don't know how much time you have. But if it's necessary for you to cross the realism threshold to learn what you need to learn, then certainly it sounds like you do need to cross the realism threshold. But consider those different variables and those different ideas as you're weighing these three principles of user testing and trying to understand how necessary realism is to your process. That's why it's important to have an outcomes over output mentality. Think about the outcome and what you're trying to learn and what you're trying to achieve and what you want that product to be, not just the output and what your favorite tool is and the kind of prototypes that you like to make. Doing so will make you a more valuable team member. It will help you and your team and your organization to learn more quickly, and to be more sure of the decisions you're making. And that's all I have for you.